Hi, Algebra 2 students. Here's our last piece of notes for this week. Now, we've practiced solving triangles just now using the law of sines, and it worked when we were given angle, angle, side, and angle, side, angle. But there's one other situation that we can use the law of sines, and that's when we have side, side, angle. Now, because side, side, angle is not a triangle congruence theorem, we call it the ambiguous case because we have to do a little bit of work in order to figure out how many triangles are actually possible in this situation. Because it's not a congruence theorem, we are not guaranteed one triangle. We have a situation where we could have no triangles that work, one triangle that works, or two triangles. So in order to start making those decisions, we first look at the angle A that we are given, and then we start comparing angle A to side length A to side length B. And if A is less than B, then we have to move on to comparing A to the height of the triangle. So we're going to use this chart throughout all of these problems with the ambiguous case. And again, the ambiguous case is when we are given two sides and an angle. We'll use this chart to determine how many triangles are possible, and then we will solve that one or two triangles. When we solve the triangles, if there's one triangle possible, it's very straightforward. It's like exactly the same as what we just did. But if there are two triangles possible, we'll solve the first one, again, just like we have been. But then when we solve the second one, we need to determine the measure of angle B. And since angle B1 and angle B2, both of the possibilities, have the same sign, that means that they have the same reference angle. See how this connects to a unit circle and all those fun things? Because they have the same reference angle, that means that they are supplementary. So in order to find that second measurement, we subtract the first one from 180. Okay? And then we'll go ahead and solve that second triangle. Let's give this a go. Here's our first situation. It says a landscape architect is designing triangular flower beds. Determine the number of different triangles that he can form using the given measurements, then solve the triangles. Okay. So first thing I notice is the measure of angle A is 55, and that's acute. So now I need to look at the length of side A and side B. A is less than B, which means that I now need to compare A to the height of the triangle before I can move on. So I'm going to draw out a triangle. It just helps me. I'm going to label what I know. This is 55. This would be 9. This would be 6. And the height of the triangle is right here. And we just use what we know from SOHCAHTOA to find this height, because this height is opposite from the angle. So the sine of 55 degrees equals opposite over hypotenuse. And in this case, the hypotenuse is 9. We'll go ahead and multiply both sides by 9, and then we'll know the height of the triangle. So I'm going to grab my calculator. I'm sorry I didn't have it open already. And we are going to multiply the sine of 55 by 9. And I get a height of 7.4. So what I see here is that A is less than the height. So let's go back to that chart, okay, and look at what that means. If A is less than the height, no triangle is possible. All right, no triangle. Let's go back and write that down. That's not going to be possible for this landscape architect. Not possible. That's our solution. Okay. Let's try this next one. My guess is this one will be possible. All right, A is acute. A is less than B. We need to find the height. So again, let's draw out this triangle. I'm going to draw it on the left here, just because I know we'll probably have to do some solving this time around. This is 35. This is 8, 9. We'll drop that height in here. And remember, opposite over adjacent. So we can do the sine of 35 equals the height over 9. Multiply both sides by 9. Back to our trusty calculators. All right, sine of 35 times 9 is 5.16, so 5.2. And that means that A is greater than H, and then B is greater than H. So let's go back and look at that chart. A is greater than H, and B is greater than A. All right, that's what we have. Two triangles are possible. Okay, so since two triangles are possible, we're going to solve it first with angle measure B1. So we'll start with what we know. We know that we have the sine of angle A, so sine of 35 degrees, goes over 8, and we're going to solve for angle B. And we know that we'll find the sine of angle B over 9. Cross multiply and divide. Grab my calculator. All right, sine of 35 times 9, and then divide it by 8, and then take the inverse sine of that. And I get angle B, and I'm going to call it angle B1 because we know there's going to be two of them, is 40.2 degrees. We'll go ahead and keep solving the rest of this triangle. So we know that we've solved for B. Let's solve angle C next because that's easy. We just subtract from 180. So angle C1 will be 180 minus 40.2 minus 35, 104.8. Now that we know angle C, we can solve for C, side length C. So we've still got our sine of 35 over 8 equals the sine of that angle C, 104.8, all over side length C. Cross multiply and divide. So sine of 104.8 times 8 divided by sine of 35, 13.5. Okay, so there we have it. This is all of the measurements needed to solve triangle option 1. But now we're going to solve the second triangle because remember, two triangles are possible in this case. I'm going to use the space up above to do my work. So I'm going to erase this old stuff. All right, so we're still working off this same drawing, but this time around, we don't have to solve for B1 or for angle B using the law of sines. Remember we said that because they have the same sines, they have the same reference angle, which means they're supplementary. So B2 is just going to be 180 minus 40.2. 139.8. We will have to use the law of sines to find side length C, but we can find the measure of angle C pretty quickly here. So 180 minus 139.8 minus 35. 5.2 is that angle. Last thing we need to find is the length of that C2. We'll use the law of sines to do that. We're going to still use that sine of 35 over 8 because those are our given. We always want to go back to our given if possible. That'll be sine of 5.2 over C. Cross multiply and divide. So in your calculator, we're taking the sine of 5.2, multiplying it by 8, and then dividing it by the sine of 35. And I get 1.3. And there we go. We have solved for both of those triangles. The ambiguous case isn't necessarily the most fun, is it? It's a lot of work, but it's repetitive work. It's tedious. There's not a lot that's brand new, except for being able to read through this chart and go through those steps. Let's just review the steps. First, we use the values that were given to determine the number of triangles. Sometimes we have to find the height, sometimes we don't. We use the law of sines with what we're given. And then if there's a second triangle, we use the law of sines a second time with that second angle B measurement that we get by subtracting the first angle B measurement from 180. I've got one more problem here for you to try in your notes. I've got the answers right here. So why don't you try working through it and then come back and check this answer. If you have questions as you go through your week, make sure you come to office hours to get those answered. And I hope you all have a good week. Take care.